Morning, everyone. Welcome to the third day of our conference. It is my pleasure to introduce our next guest, Dr. Mahmoud Abu Elella, a lecturer from Cairo University and the University of Reading in UK. Mahmoud is a lecturer in polymer chemistry at the Department of Chemistry, Faculty of Science, Cairo University in Egypt. Receiving both his master's degree and PhD in polymer chemistry from the same institution. Recently, he joined the School of Chemistry and Pharmacy, University of Reading, UK, as a postdoctoral researcher from May 2021 to March 2025. With over 12 years of research experience in polymer science, his work has focused on the synthesis and the development of polymer formulations, including grafted copolymers, hydrogels, scaffold materials, polymer nanocomposites, nanoparticles, nanostructured lipid nanoparticles, polymer-coated liposomes, nanoemulsions, polymer-coated silica nanoparticles, and spray-dried microparticle powders for biomedical application. He has also developed mucoadhesive inhalable polymeric powders using 2 fluid and 3 fluid nozzle spray drying techniques for pulmonary and nasal drug delivery. He has a strong record of interdisciplinary collaboration, project leadership, scientific publication, and grant-supported research, being recognized among the world's top 2% scientists in 2023, 2024, and 2025. His work today will be on recent advances in polymer in modified chitosan-based drug delivery system for transmucosal applications. Mahmoud, thank you very much for accepting to present your work today. The floor is yours. I will take care of the presentation. And please.
Yes, thank you so much. Can you hear me clearly? Can you hear me?
Yes, we can hear you.
Yes, thank you so much for this introduction, and thanks, sir, for sharing my screen. Can you just help me to moving the slide, because I have some problem in my laptop. Just I joining by my phone. If possible, I can start now. Okay?
Yes, please.
Thank you so much. My title today is about recent advance in modified exam for transmucosal drug delivery. Yeah, my title today about transmucosal drug delivery system. Transmucosal drug delivery system is one of the most attractive administration route for delivery of drug into the action site. In transmucosal drug delivery is already referred to administration of the drug across mucosal surface or mucosal membrane. On the bottom, like in the image on the bottom right, is a schematic of mucosal membrane. Mucosal membrane already includes two different parts. The first part is most important, is mucosal layer. Mucosal layer is already highly molecular weight, composed of highly molecular weight glycoprotein, and mainly is negative charge. Another part is epithelial layer. About the mucus layer is already includes glycoprotein plus branched oligosaccharide side chain. It's already very important to make this mucin as sticky and hydrate, and already play key role in nuclear addition theory. So it's already helped to interact with drug or polymer on action site to already prolong residence time. Move slide, please. So, according to the delivery of the drug across mucosal membrane, the mucosal drug delivery has highly or remarkable advantage rather than conventional drug route. For example, one of the most advantage of transmucosal drug delivery is enhanced drug absorption across or through mucosal layer. Another advantage is avoid first pass metabolism that already happen in conventional drug routes. Another one is already improve bioavailability of therapeutic agent and improve residence time of therapeutic agents. especially with help of mucoadhesive polymer as a carrier. So another advantage already can enable to controlled and targeted drug release. And the final advantage is already rather than conventional drug route is reduced drug degradation in harsh physiological environments. So the mucoadhesive polymer play remarkable role for migrate or for delivering of therapeutic agent to action site. For example, is already mucoadhesive polymer already play important role to prolong contacts between drug and absorption site and increase drug residence time and absorption efficiency. So in the image on the bottom right, the already as an imagination of mucoadhesive polymer already include different charge according to this classification, according to its type, is already maybe can carry a positive charge or negative charge or neutral, is already no problem. According to it is interaction with mucosal surface is already can direct the therapeutic agent to different mucosal surface like oral, like buccal, sublingual route, like ocular route, or nasal route, or vaginal route. This is already mucosal surface according to site. Next slide, please. So in this slide, where I can show some classification of mucoadhesive polymer is not obligatory classification. So it depends on the source, maybe natural or synthetic, maybe water soluble or non-soluble, maybe like for example source not natural like chitosan, synthetic like carbol or polyacrylic acid or polyvinyl alcohol. Maybe some mucoadhesive polymer according to water solubility, maybe water soluble like polyacrylic acid, or basic medium like pyridine group or imidazole group or vinyl polymer. According to it can be classified mucoadhesive polymer according to natural bonding. Maybe some polymer act as act by mucosal surface by covalent bond, some act by hydrogen bond, some act by electrostatic bond like ketosane today. Another classification according to charge, maybe cationic like ketosane. My target today, ketosane is one of the top mucoadhesive polymer, or an ion like alginate or polyacrylic acid, or neutral charge like polyvinyl alcohol. Next one, please. So in general, basically, already mucoadhesion process already can contact or can contain two mini steps. Two mini steps already is the first one, contact stage. Contact stage is or delivery stage. Delivery stage is delivery of drug included or covered by mucoadhesive polymer and journey to mucosal membrane. This is already the first stage. Just arrive to mucosal membrane, just should move to a next step. Next step is consolidation stage. Consolidation stage is mean bonding stage. It's already actual bonding between mucoadhesive polymer with mucosal membrane. This already can be happened by different interaction bond like covalent bond, electrostatic bond, hydrogen bond, hydrophobic bond, or van der Waals force interaction. Second please. Next one. So the, why already I focus today on ketosane. Ketosane already one of the most or the top of mucoadhesive polymer. Depend on many remarkable feature like natural origin is already derived from chitins, crushed shell through partial deacetylation. Is the number one. Number two has some good properties like biocompatibility, like biodegradable. So after degradation inside the body, it can degraded by without any toxic byproducts. Another feature, another advantage is non-toxicity, low immunogenicity. So minimize the side, minimize the minimize immune reaction and side effect. We can move into another advantage is mucoadhesive properties. Hawaii already is one of the top mucoadhesive properties, one of the top mucoadhesive polymer, because already has positive charge, has already amino group in the backbone can interact by negative charge of mucin. So enhance adhesion and prolong retention. They increase the retention of the drug or the therapeutic drug on mucosal surface. So another advantage and very important cell penetrating ability can facilitate the drug transport across epithelial barrier is already not always in the another mucoadhesive polymer, just in ketosane, and improve the absorption. And another advantage already has very reactive function group like hydroxyl group and amino group. So it already gives for scientists many facilities to make a lot of chemical modification to improve its solubility, because already ketosane is the main drawback is already soluble in acidic medium. But when you already according to very reactive function group, can you give availability to further chemical modification that already I will present today after these slides to already give more. Okay, sorry, back. Yeah, this stop here. Sorry, thank you. Already, this chemical modification gave me good ability to improve its solubility. It is charge and increase the electrostatic. Beside this electrostatic charge, can already add another charge is covalent bond. All of them improve and enhance residence time of drug, therapeutic drug on mucosal surface. And the last feature of ketosane is it has already multi-function biological activity like antimicrobial, anti-inflammatory, antioxidant, wound healing, and hemostatic activity. Next one, please. So, already according to your reported article, different formulation have been done on ketosane like hydrogel, nanoparticle, liposome, nanofiber, microparticle, nanoparticle, beads, tablet film. Different formulation and drug dosage have been done on ketosane. Next one, please. So today I can show some chemical modification on ketosane to how to improve the mucoadhesive properties of ketosane based on functionality based on chemical modification. The first one, Thiol functionalized ketosane. Thiol functional ketosane is Thiomer, is another name, no problem. Is already Thiol functional ketosane is already depend on how to create Thiol group on ketosane backbone to improve the interaction, sorry, to improve the mucoadhesive properties within thiol bond. Already on the left hand side is already mucosal surface. Mucin has thiol group is depend on the first image in my slides, in the first slide. So here, according to Thiomer is functionalized examined by thiol group, is already has thiol group. It can interact by SS or thiol the bond with cross mucin membrane to give high chemical covalent bond interaction between ketosane as a carrier with mucosal surface. On the right hand side is already different thiolating agent can add it on ketosane to create thiol group like cygolic acid, cysteine, and another one. Second slide, please. No. Next slide. Yes. Another modification, acrylate and mesacrylate function group. I can acrylate to acrylic group. I can create acrylate group or mesacrylate group on ketosane depend on reagent, acrylic starting reagent. Like here, I can interact ketosane with mesacrylate group to create mesacrylate ketosane, and another one is already I can interact ketosane by polyethylene glycol diacrylate to create acrylated ketosane. Both of them can interact by thiol group on mucosal surface within thiol-ene bond. Is already another covalent bond can enhance the absorption, enhance the adhesion of mucosal membrane, or sorry, adhesion of mucoadhesive polymer on mucosal membrane. And another advantage after that can prolong residence time of therapeutic agent. Next slide, please. The last modification already in minimized function. This is one of the most attractive functionalization of ketosane these days or recently. is depend on created maleimide group on ketosane backbone. Is already can improve the interaction beside electrostatic interactions that already mentioned by ketosane itself, can interact covalently by thiol in bond with mucosal membrane. All of them can improve the residence time of therapeutic agent on mucosal membrane. On the right hand side, one derivative on how to create maleimide group on ketosane by using 6-maleimide hexanoic acid as maleimide group agent. Second one, please. Yes. In mucoadhesion, already there is, according to reported articles, there is 3 different techniques can measure mucoadhesive properties. The first one, the most measured or the most used technique is the fluorescence technique. In the fluorescent microscope, the fluorescence techniques can use fluorescent agent like sodium fluorescein can interact by ketosane, and after that you can use the fluorescent microscope to measuring the retention between mucoadhesive polymer and the mucosal membrane. Already I will show the next slide, but here another technique is texture analyzer. Texture analyzer can measure the force detachment or the force between force contact between mucoadhesive polymer and mucosal membrane. There's another thing, dynamic light scattering. I can't use the nanoparticle. No, I can just here I using this technique to measuring the zeta potential. The difference in charge, net charge. How about net charge is already decrease or increase? How about the starting mucosal membrane? Mucoadhesive polymer is already net charge is positive or negative, and after interaction by mucosal membrane is already negative charge increase or decrease. This refers to the interaction between mucoadhesive polymer with mucosal membrane. Next, please. Here, just I catched. I use some real experimental data from my manuscript that is still under editing, but I need to show for attendee or our listener how to use fluorescent microscope, how can use fluorescent technique to measure the mucoadhesive retention between mucoadhesive polymer and the mucosal surface. So on the left hand side, by using flow through technique. This technique I can use it before measuring by fluorescent microscope. The first technique, flow through techniques, already I can prepare mucosal tissue and I put the mucosal membrane. Sorry, I can put on the mucosal tissue. I can put mucoadhesive polymer included drug. After that, I can using the fluid according to the mucosal surface. If I working on nasal tissue, I can use artificial nasal fluid like my example on the right hand side. After collecting the solution, I can measuring the tissue. I can see dyed tissue or by fluorescent material. I can measure it by fluorescent microscope. I have here, for example, or 4 materials. The ketosane on the top, the second one, the maleimide ketosane, different degree of substitution, like 5.8. Another maleimide substitution, 10.1, increase the amount of maleimide group. Last one, sodium fluorescent as a negative control. If you see after washing by artificial nasal fluid, after 2.5 ml, just the fluorescent green color of ketosane and all of them should be decreased. But as a negative control is already black from 0 until 30 ml. Ketosane already the fluorescence intensity is decreased, but maleimide still has, especially 10.1%, still has green light until the end, until the 30 ml. Next slide, please. By MSG software, I can collaborate the data or analyze the data about mucosal retention. If you see already at 0 time, it's already all of them 100%. But after washing 2.5 ml until 30 ml, the mucosal retention is decreased, should be decreased. but still maleimide by blue column is still high from starting until the end. But after washing by 30 ml of artificial nasal fluid is still 25 tension. It's about the kidzen is very, very low, like 5%, but maleimide is still high. High because already two different interaction. Electrostatic interaction from ketosane backbone, and in addition to electrostatic interaction, can interact by maleimide group with Sial group on mucosal surface by Sial in bond. This covalent bond increase or enhance the mutual exchange progress after a high amount of motion of artificial nasal fluid. This is the main target from chemical modification of ketosane. Still, chemical intention is still there until plus this improves this type of drug into the blood in the action site. This is the main target from nucleotidic polymer. This is the main target from chemical modification of ketosane itself. Another slide, please. Thus, I will delay this presentation to next PRIOCHEM conference. There is still our review with cooperation with Japanese collaborator is under registration in chemical society. What is the role of nucleotidic polymer in regenerative medicine application? I will delay it next, hopefully in next conference. Next slide, please. Hello. This I would like to announce about my books in market by 2026. Nucleotidic polymer in different polymer formulation. They will be published in next hopefully. Next one, please. Another cooperation with Anton was already hopefully to publish our book together but after receiving full approval from Babshab. Next one, please. Thanks so much for my team across 10 different countries, different collaborators, and different colleagues within 10 different countries. Next one, please. Next one, please. Thanks so much for your understanding. Any question, please?
Thank you very much, Mahmoud, for your efforts to present a brief overview of your work this morning. So if we have any questions from the room or from the online participants, it seems that it's a little bit early for questions. Thank you very much, Mahmoud, for your presentation. And I do invite you when you will have the possibility and the time to visit our institute, as we also have a very strong group, group in polymer science and in Kitosan, and I'm sure you will find some common interests. Thank you once again.
Thank you so much. Thank you so much. Thank you so much. Have a nice day. Bye-bye.
So our next speaker will be Dr. Gianluca Viscusi. Gianluca graduated in chemical engineering in 2016 with full honors at the Department of Industrial Engineering of the University of Salerno. Since 2015, he has been a teaching assistant of fundamentals of chemistry. After spending a 5-month period in the CSIC Center of Valencia, through an Erasmus project, he participated in the Research and Innovation Staff Exchange of Graphene 3D project, spending research periods in Sichuan University and the Mackenzie Presbyterian University in Brazil. In 2021, he got his PhD in Industrial Engineering, which concerns the design, production, and characterization of novel materials obtained from sustainable polymers and hemp fibers. Currently, he is a fellow researcher and adjunct professor of chemistry at the Department of Industrial Engineering, University of Salerno. His main research, just a moment, to allow. Okay. His main research topics concern relation between microstructure and physical properties of polymers and polymeric composites, design, fabrication, and characterization of physical properties of natural fibers based on composites, production of nanocomposites and microcomposites obtained through electrospinning, as a sustainable system for tissue engineering and water remediation, application of mechanochemistry to design advanced materials, and the synthesis of novel smart materials for removing pollutants from water effluents. The lecture today will be on green approaches to design novel adsorbents for water decontamination. Gianluca, thank you once again for accepting to present your work in our conference. You have the floor.
Thank you. Thank you so much. Please confirm that you can hear me.
Yes, we can hear you. We can also see your presentation.
Okay, let me set it in presentation mode. Okay, thank you again for your presentation. Good morning to everyone. It's a pleasure for me to join this interesting conference. And first of all, let me thank the organizing committee for this invitation, and especially my friend and colleague, Professor Anton Ficai, for this invitation. And as anticipated by the chairman, today I would like to discuss about some green and novel approaches to design novel adsorbent and photocatalytic material for water decontamination. Briefly, I'd like to introduce you the background of this presentation. As probably all of you know, the water pollution is a great concern, especially in the last decades, due to the contamination of water effluents, which can be mainly ascribed to the presence of different chemical compounds, such as organic dyes, heavy metals, pharma compound, oil traces, pesticide traces, and so on. But the presence of this contaminant is representing a great concern since water is not usable anymore as drinkable water or for agricultural application. And this is causing several problems on human health and environment contamination. Different technologies have already been applied to solve this problem, but probably the most convenient one is the adsorption process. This process belongs to the physical chemical processes to remove contaminants from wastewater. It is an easy process to carry out. No specific reagents are required. It is a reversible process, but actually the actual technology is still cost prohibitive and the cost of regeneration of synthetic adsorbent is too high. So the scientific community is now prompting the design of novel kind of adsorbent, starting from biomaterial or agro-waste resources, such as natural clays, biochar, agro-waste resources, and cellulose-based material. So the first approach concerned the use of natural fibers for the design of sustainable and eco-friendly adsorbent. Hemp fibers belong to the class of natural fibers, and they appear to be a promising candidate for the design of novel kind of adsorbent for water decontamination. It's an interesting class of material since it is characterized by biodegradability, low density, low cost, and ability to absorb carbon dioxide and heavy metals from soil. Moreover, let me say that we are discussing about the least valuable part of hemp fiber of the cannabis sativa plant, the part that is not used for pharmaceutical, nutraceutical, or for food application. And usually this part, we mean the steel, is burned to recover thermal energy. But despite the advantages of this material, there are several drawbacks related to the high wettability, low biological resistance, the flammability, of course, and the scarce adsorption properties. Without any specific chemical or physical functionalization, this kind of material did not show any great adsorption performance. So here I would like to introduce you several approaches to modify the surface of this material in order to improve their adsorption properties. First approach concerned the use of a double-step process to modify the surface of hemp fiber through a first precipitation of aluminum hydroxide in order to activate and modify the surface of hemp fibers, followed by the co-precipitation of copper oxide nanoparticles on the surface of hemp fiber in order to design a novel kind of adsorbent for removing several classes of adsorbent. Anionic dyes, such as methyl orange and non-steroidal anti-inflammatory drug, such as PRIOCHEM and diclofenac sodium salt. Here you can see some preliminary characterization of this novel adsorbent. On the left side, you can see the PCNM fibers, and on the right side, the copper oxide modified one. It is possible to observe the typical macro and nanostructure of copper oxide on the surface of hemp fibers. The ADS analysis confirmed the presence, the homogeneous presence of copper and aluminum on the surface of natural fibers, while from the spectroscopic analysis such as FTIR and XRD, we can prove the effective presence of this metal oxide. A preliminary adsorption test was carried out just to compare the adsorption of copper-modified hemp fibers with the pristine hemp fibers. You can see the adsorption capacity profile on the left side, and it is possible to observe a great and noticeable increase in the adsorption capacity towards the removal of methyl orange from water effluents, which can be ascribed to different factors, such as the increase in specific surface area and the increase in positive adsorption site due to the presence of copper oxide. In less than 1 day, 24 hours, this material is able to fully decolorize 50 ppm methyl orange-based solution, as you can see from the picture in the middle, which is a further proof of the performance of this novel material. Then several process parameters were varied just to optimize the adsorption performances of this material. As far as the temperature concerned, the process seems to be slightly favored as the temperature increase, which can be actually ascribed to the increasing kinetic energy of the adsorbate and in decrease in the diffusion barrier. As far as the initial concentration concerned, the increase in driving force between the solid and liquid phases led to a really noticeable increase in adsorption capacity up to about 250 milligram per gram. While as far as the solid liquid ratio, as expected, actually an increase in adsorption in adsorbent ratio led to the decrease in adsorption capacity and an increase in the removal efficiency due to the increase in the free and available adsorption sites, which can be used to recover methyl orange ions from water effluents. pH is probably the most crucial factor because it is known to affect either the properties of the sorbent or the properties of the adsorbate. This process seems to be favored in acidic condition. In acidic condition, methyl orange, since the pH is below the pKa of the molecule, it is supposed to exist in its anionic form, in its cationic form. So repulsive phenomena is supposed to occur between the cationic form of methyl orange and the cationic surface of the copper modified hemp fibers. But despite this repulsing phenomena, the great adsorption capacity can be ascribed to the interaction between the positive sides of copper oxide and the negative sulfonic group of methyl orange. While as the pH increase, the surface of the sorbent is supposed to be negative charged and the methyl orange is supposed to be in its cationic form. Moreover, at a really high pH, the double bond nitrogen of the methyl orange ion is supposed to be strengthened. So the diffusion and the movement of this molecule is limited, justifying the experimental adsorption data. From a chemical engineering point of view, it could be interesting just to start thinking about the design of a single-stage batch adsorbent. So by coupling the equilibrium law with the Langmuir isothermal model, it is possible to obtain a relation between the mass of the sorbent required to treat a specific volume of methyl orange solution by setting different removal percentage. So for example, in order to treat 1000 liters of methyl orange solution with a removal of 80%, just 150 grams of copper modified hemp fibers are required. But not only anionic dyes, this kind of novel adsorbent is even able to remove other kind of compound, such as pharma compound. Two pharmaceutical compounds were tested, such as diclofenac sodium salt and PRIOCHEM. They belong to the non-steroidal anti-inflammatory drugs. And it's possible to observe that the copper modified adsorbent is able to fully remove PRIOCHEM and remove about 50% of the chlorphenac sodium salt from the initial water solution. And this difference can be mainly ascribed to the polarity and sterical entrance of the two molecules. Regarding selectivity, we test the ability of these novel copper modified hemp fibers to remove selectivity, a specific adsorbent in real wastewater scenario. So in the first case, regarding the mixture between the two pharmaceutical compounds, the adsorbent appears to be selective in removal PRIOCHEM instead of the chlorphenac sodium salt, which can be ascribed, as previously reported, to the chemical structure and properties of these two molecules. While regarding organic dyes, we tested the selectivity in removing 3 different anionic dyes, Concord, methyl orange, and acid yellow 7D. And the adsorbent is able to fully remove Concord and methyl orange and to remove about 60% of acid yellow 17. Regarding the recovery, you can observe on the right side that there is just a slight decrease, 2, 6, and 9% of adsorption loss after 10 cycles of adsorption-desorption, proving again the performances of this novel adsorbent. A further approach concerns the modification of hemp fibers through a single-step approach by modifying it firstly with an organosilane and then with graphite oxide in order to design and to fabricate a novel adsorbent for the removal of cationic dyes such as methylene blue. Here you can see the graph before and after the modification, where you can observe the typical structure of natural fibers. The ADS map proves the homogeneous presence of silicon belonging to the organosilane and the nitrogen belonging to the graphite oxide and organosilane. Regarding the chemical functionalization, the FTIR prove the the formation of a siloxane group and silanol group between the silicon element belonging to the organosilane and the OH group belonging to the hemp fibers, while the convolution spectra from the OH band of FTR analysis prove the presence of the OH band stretching belonging to the graphite oxide. Then a preliminary batch study was carried out to compare the adsorption of the graphite oxide modified hemp fibers with the pristine one. Here you can observe an improvement, and noticeable improvement in adsorption capacity, which can be ascribed even in this case to the increase in specific surface area, increase in porosity, and the high availability of the available adsorption sites on the surface of hemp fibers due to the presence of a negative group of graphite oxide. Even in this case, in less than 24 hours, this material is able to decolorize a 50 ppm methyl blue initial solution, and you can observe the colorimetric change on the bottom side of the solution from the dark blue to the transparent water. Then several process parameters were changed to evaluate deeply the adsorption performances of this adsorbent, such as pH, temperature, deconcentration, salt presence, and adsorption dosage. But I would like to focus on the reusability test. As you can see, after 30 cycles of adsorption-desorption, the loss is about 50%. So this adsorbent is able to preserve its capacity in removing methylene blue from the water effluents. And since the presence of geo-leaching, we studied the leaching occurring phenomena, which can be ascribed to the desorption of graphite oxide macro and nanoparticle from the surface of hemp fibers. And you can observe that after 240 hours of a continuous use of graphite oxide modified hemp fibers, the geo-leaching concentration is about 0.15 microgram per liter, which is below the threshold established by the European Community for this compound. And this data can be merely ascribed to the covalent binding, as discussed previously from FTR data of graphite oxide to the silent modified hemp fibers, which is supposed to occur between the amine group of the organosilane and the carboxylic and epoxy group of graphite oxide. Then in some cases, it could be interesting to use novel and advanced technologies to remove specific pollutants such as structure membrane. Structure membrane appears to be an interesting class of material to remove contaminants since they can act as barrier to prevent the movement of specific contaminant. In organic and inorganic material, several membranes have already been applied to remove different kinds of contaminants, and several fillers have been explored, such as metal oxide, metal organic framework, carbon nanotubes, cellulosic-based material, and so on. But in the last decades, carbon quantum dots appear to be an interesting class of material since they can confer specific adsorption sites for the removal of a wide class of contaminant. In this case, we use nitrogen-doped carbon quantum dots produced by using an agro-waste resource such as sugarcane bagasse. This is a work in collaboration with the National Research Center of Giza in Egypt. And in this case, a novel and sustainable approach was used to fabricate and to dope the carbon quantum dots, which were used as filler inside the cellulose acetate electrospool membrane to design a novel class of membrane as a barrier for the removal of a specific contaminant from wastewater. Here you can see the morphological analysis of pristine cellulose acetate electrospool membrane before and after the introduction of nitrogen carbon quantum dots. You can observe a more disordered structure which can be ascribed to the presence of the aromatic group of nitrogen carbon quantum dots, which can lead to the increase in conductivity and instability of Taylor's cone in the electrospoon process. So this can justify the disordered structure, the reduction in fiber diameter, and the increase in specific surface roughness. The effect of the loading of nitrogen-doped carbon quantum dots were studied. It's possible to observe that just a small concentration, about 1%, is sufficient to obtain really great adsorption performances, and it was not possible to go over this concentration since the instability generated by the filler inside during the electrospinning process. Then, as usually, different process parameters were varied and tested just to discuss and to evaluate it and to study the adsorption performances of this new material, such as the solid liquidation, the initial concentration, the temperature, the pH, the presence of salt as well. And in all these cases, it is proved the adsorption performances of this new material to remove organic dye from wastewater with a maximum adsorption capacity proved by Langmuir model equal to about 300 milligram per gram. Even in this case, this novel material was applied not only to remove methylene blue from water solution, but even other cationic dyes such as crystal violet and rhodamine B. In this case, the membrane is able to remove about 90% and about 70% of these two cationic dye from water solution, proving the ability to be used for different classes of contaminant. Usability test, even in this case, proved that it is possible to use again this membrane by removing the cationic dye just by soaking the membrane in a water hydrochloric acid solution in order to remove the adsorbent dye. So this membrane can be used again, proving again the adsorption and the capacity of this membrane and justifying the economic feasibility of the adsorption process. A further approach concerns the use of a polymer that usually it is burned. It is a synthetic polymer. It is not a natural polymer that usually it is recovered from windshield. So from the recycling of the windshield derived from cars or from automotive industries. This polymer is the polyvinyl butyrol, which can be used to produce a novel kind of membrane by applying the NIAPS process and by using copper oxide nanoparticles in order to improve the adsorption capacity of this novel membrane. Here you can observe the surface, the top surface, and the cross-section image of the polyvinyl butyrol doped with copper oxide nanoparticles. You can observe the porous structure, which can be induced by the NIAPS process, which is mainly related to the use of a solvent and dissolvent process, and the formation of a finger-like structure in the cross section, which can be used as channel for the removal of different kind of contaminants. In this case, we applied this membrane for absorbing oil traces from emulsion, so from oil-water solution. Even in this case, different kind of parameters were changed. You can observe on the right side the optical images before and after the adsorption. So the typical emulsion drops can be completely removed after the application of the PVB copper oxide doped membrane. So this membrane is able to selectively absorbing oil. So in this way, proving the ability to separate oil from water. The maximum adsorption capacity is about 1,400 milligram per gram, proved by the application of a Langmuir model. A further approach would be based on the use of bio-based hybrid hydrogel and aerogel. This first work concerned the use of soybean extract beads loaded with hemp heart and halloysite, a natural clay, for methyl blue adsorption. So in this case, we use all natural resources, agro-waste resources, such as soybean extract, hemp heart, which is the less valuable part rich in lignin, derived from hemp fibers processing, and the halloysite, which is a tubular natural clay for removing methylene blue from water effluent. So even in this case, we tested the effect of the natural clay on the ability of this adsorbent to remove organic dyes from wastewater solution. You can observe the change on surface color of the beads before and after the adsorption process, which can be mainly ascribed to the presence of specific groups conferred by the hemp heart, especially carboxylic group and aromatic groups, and the silicon oxygen group provided by the natural clays. This work was done in collaboration with the University of Constantine in Algeria, and it is based on the production, on the fabrication of a novel kind of hydrogel beads based on the sodium alginate and pomegranate beads to remove another kind of contaminant, such as safranin dye from wastewater. Even in this case, we proved the adsorption capacity with a maximum adsorption ability of about 30.7 milligram per gram. This novel approach concerned the production of a novel kind of aerogel, starting from cactus powder and ionic liquid modification for the removal of nimesulide from wastewater, which is a pharma compound. In this case, we applied ionic liquid to modify the cactus powder, and a novel process which is based on the supercritical carbon hydroxide to remove the sorbent in order to create a really interconnected and nanoporous structure. Cactus powder derived from the cactus pear clatodes, which is an agro-waste resources, a waste material with low density, low cost, and the presence of specific functional group can be used to remove different anionic and cationic dyes from wastewater. As previously stated, in this case, we applied inotropic gelation in order to produce beads starting from cactus powder and ionic liquid, and a solvent exchange process was applied to substitute water with ethylene alcohol, and then supercritical drying, which is based on the diffusion of a supercritical carbon dioxide inside the hydrogel was applied to remove ethanol in order to produce a really porous interconnecting structure. Here it is depicted the process of supercritical drying, which is based on the transport in bulk of this fluid and the affinity of supercritical carbon dioxide with organic solvents such as ethanol. You can see here the structure of the pristine cactus aerogel modified with ionic liquid and one with ionic liquid and we were subjected to drying by applying supercritical carbon dioxide based process. So here you can see the presence of a more interconnected and porous structure which can be exploited to remove different kinds of contaminant and to entrap molecules inside the pores. Preliminary studies were carried out to remove this contaminant in the mesolide from wastewater. See, the presence of ionic liquid greatly increased the adsorption capacity, which can be ascribed to the presence of a more porous structure and increase specific surface area and increase in available adsorption surface sites. The removal efficiency is about 90% after a few hours. As usually done, different kind of parameters were changed. In this case, temperature, the initial concentration, the adsorption dosage, the pH, and the presence of sodium chloride concentration, just to simulate the real wastewater scenario. And all the data derived from these studies proved the great adsorption performances of this material in removing different kinds of pharmaceutical compound, specifically in the mesolide. The removal efficiency was demonstrated by testing again and again the aerogel beads for 10 cycles. The loss in adsorption capacity is about 10%. So this is a further proof of the ability of this aerogel to be used again. A novel approach could be based on the use of biochar from agro-waste resources, but in spite of using chemical functionalization, we applied a solid state process, the mechanochemistry. So mechanochemical treatment, which does not require any kind of increase in temperature, any kind of pressure application, and any kind of solvent to just modify the surface of biochar in order to decrease the mean dimension and to increase the porosity of this material. So this solid state process was applied to modify the biochar derived from the natural resources in order to improve the presence of the positive adsorption sites on the surface of this biochar, which can be used to remove different kinds of contaminant, especially crystal violet. Even in this case, the biochar can be used and used again. You can observe that after 6 cycles, the loss in adsorption capacity is quite negligible, and this can be ascribed to the possibility of exploiting the pores and the positive sites of mechanochemically functionalized biochar to remove these organic dye from wastewater with a maximum adsorption capacity of about 185 milligram per gram. But sometimes the main drawback related to the use of this material is the possibility of recovering them from wastewater. In order to overcome this problem, we developed novel kind of magnetic cellulose material in order to easily recover this material from water effluent just by applying an external magnetic field. In this work, cellulose derived from the rice straw was modified with magnetite, which was further doped with manganese in order to improve their magnetic properties, which can be used and exploited to recover this material from wastewater after their use. You can observe here the surface of pristine pulp cellulose, the pulp cellulose modified with magnetite, and one doped with manganese. Manganese was chosen in order to improve the adsorption and the magnetic properties of this adsorbent. The XRD analysis proved the presence of manganese and the partial substitution of manganese inside the structure of magnet, which led to the increase in the volume of structure. But as far as the magnetic property is concerned, we can observe that on the left side, the magnetic field against the temperature, and this novel material appears to show a mercury higher than 300 Kelvin. And since there are no peaks in the field cooled, zero field cooled, it is possible to state that this material resembles the behavior of a paramagnetic material, while on the left side, it is proved that the coercive field near to zero is really low, is about 4 Ørsted for the pulp cellulose modified with the magnetite doped with manganese. And this data, these performances, these properties were exploited to study the removal efficiency of this material to remove another kind of contaminant, such as Congo red, an azoic anionic contaminant from wastewater. And it is proved again the real adsorption capacity of this material to remove Congo red from water effluent with a maximum adsorption capacity of about 190 milligram per gram. Again, the reusability cycles prove that this material can be used again. And after 6 consecutive adsorption cycles, the removal rate is still high, about 80%. But it is interesting to note that the magnetic property seems to be not greatly affected by the presence of the Congo red, that it is not desorbent from the structure. So it is possible to use again this material and to apply a magnetic field from the external side just to easily recover the powder from the water solution after they're used. The last approach concerned the use of hybrid material for dye photodegradation. In this case, we applied an electrospin process again just to design a novel kind of polyurethane polycaprolactone membrane doped with a chromium titania doped catalyst produced through a salt gel sustainable process to photodegrade acid orange 7. Even in this case, we varied several kinds of process parameters. The process seems to be favored in acidic condition, room temperature, and with a 20%, which is the loading of chromium doped titania, the process, this kind of material seems to be able to more or less fully remove the acid orange 7, photodegrade actually this contaminant from water solution. So this data further prove the potential of this membrane as sustainable technology to photodegrade this contaminant from wastewaters and to be used for self-cleaning solution. So in conclusion, in this presentation, we show the possibility of adopting different kinds of sustainable and clean process, starting from agro-waste resources of, for example, polymer, synthetic polymer that can be recycled to produce novel kind of material to be used as adsorbent material or photocatalytic material for wastewater remediation. All this approach affected many areas such as environment, safety, sustainable and circular economy, because all are based on the adoption of sustainable and recycled material and sustainable and eco-friendly approach. Some of this work were carried out thanks to the collaboration with several groups all over the world, such as University of Constantine in Algeria, Relizan, Turkey, Spain, Morocco, Croatia, Greece, and Pakistan. And before moving to the conclusion, I'd like to invite all the people interested in polymer-related application to the next edition of Polymer Processing Society International Conference, which will be organized by our department, Department of Industrial Engineering of the University of Salerno, in the vibrant city of Paestum next year, between May and June 2026, in the Paestum, which is near Naples, so in the southern part of Italy. And finally, I'd like to thank all of you for your kind attention.
Okay, thank you very much, Gianluca, for your very nice presentation.
Thank you.
So, if we have any questions from
Yes.
from online,
Yeah.
yes, a short.
Yeah, thank you, Jan, for this nice presentation and analytical presented data in absorption technique. Just my question in the first part, removal of methylene orange and removal of methylene blue. Just I really confused how already the maximum absorption of methylene blue, methylene orange happened in pH, acidic pH. Also, already a lot of active site on nitrogen will be blocked by proton, and you already did you measure pH zero charge or 0 point charge or not of orbits.
Okay, thank you for your question. If I well understood, you are referring to the work regarding the methyl orange removal by using a copper modified amber fibers. Actually, the data related to the pH variation initially were quite wild, but we evaluated the point of zero charge of the sorbent, which is about 6.5. So below this value, the surface of the sorbent is supposed to be positive charge, and the methyl orange is supposed to be in its cationic form. Actually, it is in its hybrid resonance between the adzonium structure and the quinidamine structure, but we associate this data. Sorry, there is probably some more noise. We related this data to the attraction phenomena between the sulfonic group of methyl orange ion and the positive adsorption sites of methyl orange. Above the point of zero charge, the methyl orange is supposed to be in its anionic form. The surface of the sorbent is supposed to be in its anionic form, so negative charge. And so repulsive phenomena are supposed to occur. And this justifies the degrees in adsorption capacity.
Okay,
Thank you. Thank you, Mamu.
for answer. I hope this was enough for justifying. I don't think we have time for any more questions. So we thank you very much for
Thank you
being
so much.
online at least, and for your nice presentation.
Thank you again.
And we will go next to another invited speaker. So there's been a little switch in the program. The next speaker will be Associate Professor Dr. Michal Ceglowski. He graduated from the Faculty of Chemistry at Adam Mickiewicz University in Poland in 2011 and received his PhD from the same institution in 2015. Following his doctoral studies, he completed a postdoc at Ghent University in the lab of Professor Richard Hogebun. And now he is an associate professor of chemistry at Adam Mickiewicz University, where he leads a research group focused on developing functional and selective adsorbents for solid phase extraction. His work emphasizes designing materials ranging from molecularly imprinted polymers, which are tailored for the selective recognition of specific molecules, to hybrid organic inorganic materials that can be used in combination with analytical techniques to quantify persistent organic pollutants. Michal has served as the principal investigator and grant holder for 6 research projects contributing to advancements in analytical chemistry and environmental monitoring. So today he will present an interesting lecture addressing trace contaminants challenges, novel application for porous adsorbents, and molecularly imprinted polymers in ambient MS. So, Michal.
Hello, everyone. Okay, so I see now, I can be seen now. Okay, so hello, everyone again. It's a pleasure to be here again. And let me just to show my presentation. Okay.
Well, everyone tells that next time you have to be here.
I would.
Get your question.
Sorry, this year is quite unique. So sorry
if
here in person,
there are no more questions or any questions, it seems that you had a very nice presentation. So everybody understood the concept of MIP. And thank you once again for being at least online with us.
Thank you very much also for the invitation. Thanks.
Sorry. Okay, we can go forward to our last invited presentation, which is Professor Dr. Francois-Xavier Perrin. He is a professor from the University of Toulon. After graduating in chemical engineering from the University of Marseille, Professor Perrin completed a PhD thesis at the University of Besançon in France, working on the electropolymerization of phenol derivatives and heterocyclic compounds. Later on in 1998, he joined the MAPIEM laboratory in the University of Toulon, and he is a professor there since 2011. He is now currently head of the chemistry department at the University of Toulon and head of the physical chemistry and durability of materials research group in MAPIEM lab. His research activity covers heterogeneous organic matrix systems with a particular focus on the implementation of functional 1D or 2D nanofillers, notably those based on conductive polymers and nanocarbons. So today he will be presenting us a study about cementitious coatings, a realistic protective alternative to organic coatings. So, Professor Perrin.
Yes. Good morning, everybody. Can you see my presentation?
So we hear you, and you shared your presentation, and okay, perfect.
Okay. So thank you, Verona, for this introduction. I would like first to thank the organizers of the conference for giving me the opportunity to present this work. So it is somewhat unusual work for our laboratory. In fact, this research concerns cement-based coatings, whereas our lab has so far focused on organic matrix coatings.
So we liked your presentation very much, and hope that next time you will be here physically as our previous colleague. So hope we will meet here the next year. So thank you again for the presentation, and have a nice day.
Have a nice day also. Goodbye.
We didn't hear you because my microphone was on. Now you.
Yes, I would like to thank you again for the invitation, and I will try to be physically present the next time because it's always a pleasure to be in Bucharest with you.
Thank you very much. So I think this will be it for today. We end our presentations for today. We take a short break, 10 minutes, and after that we come back for the poster presentation. So thank you.
Hello, everyone. We'll proceed with the section of my poster in 100 seconds. Miss Mana Alexandra.
Hello. Hello, everyone. My name is Sevinç Osmanova from the Institute of Catalysis and Inorganic Chemistry in Baku, Azerbaijan. Today, I will present our work titled Alumina-based nickel iron catalyst for methane pyrolysis, synthesis, and structural peculiarities. I will present a presentation on behalf of Aytekin Askarova. Methane pyrolysis is an important process for hydrogen production without releasing carbon oxides, offering a carbon-neutral alternative to conventional reforming methods. In this reaction, methane decomposes into hydrogen and solid carbon, but the efficiency largely depends on the catalyst use. Among different systems, nickel-iron catalysts supported on alumina have shown excellent activity, stability, and resistance to sintering. In our research, we prepared nickel-iron alumina catalyst by impregnating nickel pyrazine and pyrimidine and fluorescent complexes onto alumina. The catalyst was characterized by different methods, including XRD, SEM-EDS, FTR, and thermal analysis. Our findings show that the catalyst remains structurally stable up to 1000 degrees Celsius and around 800 degrees Celsius. It promotes filamentous carbon formation, which helps prevent deactivation. In conclusion, the nickel-iron alumina catalyst demonstrate high thermal stability and efficiency, providing a sustainable and carbon-neutral pathway for hydrogen generation through methane pyrolysis. Thank you for your attention.
Thank you too for this presentation. Have a nice day. So
thank you.
And Miss Alexandra Manea.
Hello. Oh, thank you. So my name is Alexandra Manea from Hofigal, and the purpose of the study was to assess the microbial load of apples and the efficiency of different decontamination methods. Apples purchased from a local market were evaluated for microbial contamination before and after treatment with kombucha, apple vinegar, and water. Before this treatment, kombucha and vinegar were sterilized by heat treatment at 120 Celsius degrees for 30 minutes. Results showed that among the tested treatments, kombucha achieved the higher reduction in contamination on apple surfaces. In addition to microbial analysis, pH, total polyphenol content, and antioxidant activity were measured to better characterize the chemical properties. Between untreated and heat-treated solutions, there were no differences in their chemical properties. This study supports the use of kombucha as a natural, eco-friendly, and sustainable alternative to conventional fruit washing. Thank you very much.
Thank you too. We try again with Mr. Dinka.
Microplastic generation from artificial turf earthium. Hello, my name is Alexandra Sârbu, PhD student in environmental engineering. Also, PhD student under the guidance of teacher of Miss Maria Ripa, we created this poster microplastic generation from artificial turf earthium. In this poster, we present the advantages and disadvantages of using artificial turf spot. The advantages are the reduced water on the elimination of workplace, the recycling of carbon from tires, reduced and the use of provide constant also an economical and political alternatives. The disadvantages are that the small and problem from the tires can be a source of microplastics and nanoplastics, which pose potential risks to the environment and humanity. In order to fight this, the International Federation of Associations has to establish performance standards for synthetic with the aim of the health of the planet. Alternatives to options during work, always, and maybe coconut Following the collection values and the student of artificial cells, waste is recommended to
So then Yegana Hazayeva.
Yeah, okay. My name is Shahin Orucu from the Institute of Catalysis and Inorganic Chemistry in Baku. I will present our poster on behalf of Yegane Hamzayeva. Our poster is about the aluminium-based nickel ferrum catalyst synthesis for carbon dioxide reforming. And what's actually the DRM, dry reforming of methane? The main reaction is shown here. You can see it's an endothermic reaction, and it's used for conversion of greenhouse gases to the syngas. And as well, there are some side reactions like reverse water gas shift and methane decomposition. And one more is about the Baudard reaction. The last two one is related to the Koch formation, and it's not desirable in our case. However, our catalyst is made by the bohemite, which is the main section of our catalyst, and it will be converted to the aluminum trioxide, and nickel and ferrum composites are dissolved in normal hexane, and then our catalyst is dried at 60 degrees Celsius for 4 hours, and then calcination process happened for 6 hours under temperature of 950 degrees Celsius. And here you can see our test machine, which is our cat lab machine, microreactor, and it is used to make a test under conditions of temperature around 680 degrees Celsius, even more than that, and the atmospheric pressure. The catalyst mass used in the test is around half of gram, and the results part in the results part, you can see that our nickel component is mainly on the center of our catalyst, but while the iron is well dispersed around the surface of the catalyst, and you can see that oxygen dispersion, which is the main part of our base structure, which is aluminum trioxide, and you can see that it is well dispersed by the ferrum, nickel, and aluminum trioxide. And here you can see XRD patterns of our catalyst, and you can see that there are two methods like inorganic based and organic based. In inorganic based, you can see the higher peaks, which means that a higher crystalline structure and the more crystalline size, while in organic based one, there are wider and broader peaks, which shows the smaller crystalline size. And in conclusion, I want to say that our DRAM reaction is thermodynamically favorable for 950 Kelvin, and excess carbon dioxide effectively suppresses our Koch formation, and it prevents our side reaction, which is the formation of the Koch. So that's it. Thanks for your attention, and
thank you too, and also thanks for keeping the time. We'll move forward to Mr. Almir Abdulov.
Okay, we'll try to see if someone else is online. Ansagan Kabdelova.
Hello everyone, my name is Ansagan Kabdelova, and I'm from Kazakhstan. The topic of my project is the Aqua water filter. The goal of my project is to improve the quality of drinking water and promote waste recycling. This problem is very important because about 80% of the human body is water, and yet many people still use polluted tap or river water. And I decided to create a cheaper, eco-friendly alternative using local materials. My Aqua filter is made from shungite, xylite, and eggshells. Shungite purifies water and has healing properties. Xylite removes heavy metals and enriches water with useful ions. Eggshells contain calcium carbonate and help recycle waste. I created 4 filter models with different proportions and tested them chemically and organoleptically. The second model showed the best result with a pH of 7.75, all ion levels within SANPIN standards, and no smell or taste. The cost of one filter is only $1, which is 11 times cheaper than Aquaphor, but the quality is comparable and eco-friendly. The ANS Aqua filter can purify up to 200 liters of water and lasts for about 4 months for one person. In conclusion, ANS Aqua is an affordable, effective, and eco-friendly solution. It reduces plastic waste, helps low-income families and access clean water, and protects public health by preventing waterborne diseases. Thank you for your attention.
We thank you also for your presentation and the timeline. We invite now Abdullah Almir, if he's in online. Aizer Andosova. Kadisha Mendigalieva. If no, we'll ask Madina Malik Shabagat.
Hello, my name is Medina. I'm from INCDCP, and my project is called a mini tester for determination of processes in a food product. Introduction. According to the World Health Organization statistics, every year almost 1 ill from eating contaminated food, and 420,000 die as a result. Meanwhile, many foods are prematurely disposed because of the lack of accessible testing methods, leading to food waste and economic losses. The problem is relevant in our country, in Kazakhstan, which ranks 26 in global food poisoning risk for travels. So the purpose of the project was to create a compact mini tester for determining the processes in food products, taking into account changes in humidity, temperature, and pH during oxidation. The project aims to increase food safety and prevent premature utilization of food products. So first, we modified a commercial soil tester for food analysis. Then we reassembled components into a cardboard frame, designed a 3D model in Tinkercad for future printing, so you can see it there. And also you can see the drawings that I did before. And so we connected display for real-time data visualization, conducted chemical tests with iodine and ammonia, they are here, and measured pH of liquids and monitored for temperature, and recorded and compared digital and visual results. So here is some chemical reactions, like reaction to ammonia and amines, protein decomposition. Phenolphthalein was added to 1 month-old chicken soup. Pink color appeared, and ammonia and amines were released, indicating that the meat had spoiled. There are pictures of my testers' work. So we can see the pH of vinegar, it's 3.5, and pH of rainwater is 5.5. So results. We got a functional mini tester prototype which was assembled with pH, temperature, and humidity sensors, and a display for real-time monitoring. The cardboard housing ensured portability, and 3D model was designed for future upgrades. So conclusions: the developed mini tester provides a compact, low-cost solution for real-time monitoring of pH, temperature, and humidity in food products. It enables early detection of spoilage, helping reduce waste and improve food safety. That's all. Thank you for attention.
Thank you, Madina. You have recovered your delay for sure. Okay, we invite Nuria Amangeldi online.
So, hello, my name is Elella Andosova. I'm from school from Kazakhstan. So, my project is about para-oleum fluid, a novel magnetic nanotechnology for increased oil recovery from contaminated soil and oil spill incidents. So, oil environment challenges. Traditional cleaning methods are often expensive, slow, and leave behind toxic residues. That's why our research focuses on a new innovative nanotechnology called para-oleum fluid, designed to recover oil from contaminated soils and surface spills using magnetic separation. So what exactly is para-oleum fluid? It's a colloidal suspensions of oil-dissolving paramagnetic nanoparticles. So these particles have a strong attraction to oil and respond to magnetic fields, which makes it possible to pull the oil from the soil or water with a magnet. So in our experiment, we tested 3 different concentrations of POF, 0, 1, and 5 drops in oil-contaminated soil samples. Using an iridium magnet, we measured how much oil could be removed, and the results were remarkable. The control group without POF showed almost no oil removal, but with just 1 drop, we achieved around 50 to 60% efficiency, and with 5 drops, the oil removal rate reached about 90%. Leaving only small traces behind. So the more POF was used, the better and clean it the magnetic separation became. In conclusion, our findings show that pyrolyl fluid is not only highly effective and magnetically responsive, but also reusable, non-toxic, and environmentally friendly. So it works in both soil and water and has a great potential in large-scale industrial and disaster relief applications. With further research into the cost and field performances, pyrolyl fluid could become a next-generation solution for cleaning our planet from oil pollution. Thank you for your attention.
We thank you for your presentation. We invite Nuria Mageldi, if he's online.
Yes, I'm here.
Please, can you share your poster?
Yes, just a second. So the topic of my presentation is multifunctional material for environmental protection. So the main idea of my project is to use activated carbon to produce graphene and use graphene in water purification. So I have researched the effect that nanomaterials can have on water. So I researched a way to synthesize graphene-based graphene using activated carbon. So the method used the electrochemical exfoliation process with the use of sodium sulfate and sodium hydroxide under standard laboratory conditions. And activated carbon was used as the primary electrode material. So on the screen here, you can see the process of electrochemical exfoliation, and on the surface, you can see graphene building up. These are graphene particles. So the results of this project was the synthetic aerosols displayed porous morphology that has excellent absorption capacity. Repetitive absorption experiments confirmed that the heavy metal removal capacity, organic pollutants, and oils. Regeneration experiments suggested reusability with minimal loss of activity. So in conclusion, the study confirmed that the electrochemical exfoliation of activated carbon can be used for synthesizing graphene materials. And later, this synthesized graphene can be used in water purification systems and shows a promising solution to the issue of oil pollution in the aquatic ecosystem like the Caspian Sea. Thank you for your attention.
We thank you for your presentation. We will invite Elnaz Smadirova.
Hello everyone, my name is Elnaz and Jan. We are from ICECHIM, Kazakhstan, and our theme is eco-friendly starch production.
Our goal is to create eco-friendly starch production system using reed roots, reducing pollution from reed burning in natural and generating valuable biomaterial.
Our hypothesis, reed roots can be processed into starch, turning waste into biodegradable raw material. This reduces harmful effects like fires and allergies and promotes local sustainable production.
Reeds are invasive plants that spread quickly without ecosystem and often cause fires releasing toxic gases. These fires worsen air quality and damage soil, crops, local flora and fauna. Our solution is to use reeds as a raw material instead of burning them, helping both the environment and economic.
We developed a 5-stage step extraction process, which includes cleaning, grinding, soaking, centrifugation, and drying. For 38 grams of reed roots, we obtain 9.8 grams of starch, about 25.5% of yield. And we also conducted some tests with iodine, where we obtained purple color, and also a Benedict's reaction to glucose solution, where we also obtained red color, which proves that we obtained starch.
Reed starch can be used in food, cosmetics, medicine, paper, textiles, and even bioplastics. It's a new biodegradable alternative to petroleum-based products. Our project is eco-friendly, practical, and efficient, turning a harmful plant into a useful material. Thank you.
In conclusion, we would like to say that the starch extraction is on the basis of available components. We completely cost-effective and practical solution for home and semi-industrial conditions. Starch extracted from the roots and reeds can be used in creation of biodegradable products, which makes it a multifunctional source after research. You can see the pictures of the starch we obtained here.
Thank you for your attention.
Thank you for attention.
We thank you for your
If you have any
presentation.
questions, you can ask.
Hello, I'm Khadish and I want to present.
Us, Ayalium, Amangoskizi. I'm sorry, but it's quite difficult to pronounce this. Ayalium.
My name is Nortas, and today I am excited to present my research project on developing an electrostatic filter designed to reduce sulfur gas emissions from the Atro oil refinery. The Atro oil refinery, one of the largest in the country, emits sulfur dioxide and hydrogen sulfide, which harm air quality, human health, and nature. Long-term exposure to sulfur compounds leads to disease, soil erosion, acid rain, and soil degradation. Existing purification methods at refineries are insufficient, making new technologies essential. Thus, in this project, a new device is used to sulfur and compound gases, knowing their harm they cause to nature by analyzing them from various aspects. The main goals of my project is to create and test a multi-component electrostatic filters that can effectively capture and neutralize these harmful gases. The device consists of three main parts: an electrostatic sections that traps charged sulfur particles. Second is an absorbing layer with activated carbon and metal oxides that capture gaseous sulfur compounds. And the last one is neutralization section that uses ion exchange materials to convert sulfur ions into harmless compounds. During the experiment, I found that the filter reduced sulfur dioxide emissions by up to 85%. And hydrogen sulfide by up to 90%. These results clearly prove that the filter is highly efficient and has strong industrial potential. This project is important not only for Atro, but also for the entire country. It contributes to Kazakhstan's environmental sustainability goals, offering a practical and innovative solutions to reduce industrial air pollution. In the future, I plan to develop and upgrade my device, making it more efficient, automated, and suitable for large-scale industrial use. I strongly believe that my project has great potential to become a real practical technology that will help create an cleaner and healthier environment for future generation. Thank you for attention.
Thank you to Nurim. So Khadisha, you can present your poster now, please.
Hello. Hello everyone. My name is Khadisha and I'm from NIS Kazakhstan. Can you see the poster?
Yes.
Okay, thank you. So today I'm going to talk about my project, which is solution. So as you all know, air pollution is stealing the clean air we deserve, harming our health, our planet, and our future. That's why I created solution, a small but powerful purifier made for the heart of our cities. It works quietly where life happens, in schools, in hospitals, parks, and streets, giving people something priceless, fresh and safe air. Here's how it works. Contaminated air enters the system through a compressor and detectors. It passes through a spiral tube filled with the calcium hydroxide solution. So inside, some chemical reactions occur, as you can see in the poster. So these reactions turn toxic gases into stable, harmless, and even reusable solid byproducts, such as gypsum and calcium carbonate. In our experience, the device processes 120 liters of air per minute with just 35 watts of power. It removed 84% of SO2, 8% of NO2, and 80% of CO2. Solution is low cost, mobile, and eco-friendly. But beyond technology, it's
also a symbol of environmental action, showing that innovation help clear and healthier cities. Clear adoption is essential, and solution is our step forward to make it a reality. Thank you for your attention.
Kadisha. We'll pass to Ayaulim. No? Amanat Chapai. Talab Aymanur. Or Medina Daoud.
We face a serious problem. Landfills are overflowing, illegal dumps are spreading, and traditional waste management methods no longer work. Burying or burning trash pollutes the air, water, and soil. So what if instead of throwing waste away, we could turn it into energy? That's where my project, Refuse-Derived Fuel, or RDF, comes in. So RDF is made from non-recyclable waste such as plastics, textiles, and paper. It burns almost as strongly as coal, but it still produces harmful gases such as hydrogen chloride, sulfur oxides, and dioxins. So my research explores how to make RDF cleaner and smarter. I tested adding small amounts of simple, affordable chemical additives into RDF briquettes such as calcium carbonate and calcium hydroxide. They help neutralize acidic gases, and kaolin clay locks toxic metals in ash. Iron oxide helps the waste burn more completely, and zeolites absorb organic pollutants. So, in short, additives enhanced RDF can help Kazakhstan and whole world move toward a circular economy, turning our waste into cleaner energy and valuable byproducts. For example, after cleaning, after making our briquettes more clean, and if it will produce less toxic gases, we also can reuse the ash produced by the burning of them. And for some reason, I thought that we were not really able to put pictures in our posters, so I'm gonna show right now my bricks I made from using the ash made from the burning of the briquettes. Added like cement or water, and then yeah, I had really strong bricks. Okay, thank you. Any questions? Maybe.
Thank you, Amanat. We'll pass to Talab Aymanur. If not, Medina Daoud.
So the simple zinc oxide FTO, graphite, potassium iodine cell showed high for the current and voltage, demonstrating an effective, affordable approach for better DSSC performance. My objective was to develop and evaluate low-cost zinc oxide and the DSSC using a hybrid dye of natural plant extracts like spinach, blueberries, or other natural plants that are rich in antioxidants. And also silver nanoparticles, because they definitely improve the light harvesting efficiency and stability through co-sensitization and plasmonic enhancement. So my main methodology was like preparing zinc oxide by precipitation, then coating it and drying it on the FTO glass, extracting anthocyanins and acidified ethanol and combine them with copper sulfate and silver nanoparticles to form a hybrid dye. Using potassium iodide and glycerol as the electrolyte and apply it to the graphite. As you can see here on FTO as the counter electrode, assembling the DSSC and measuring photocurrent voltage and efficiency under simulated sunlight. I use like ampermeter and voltmeter. So my results show that the zinc oxide bed DSSC synthesized with a hybrid dye achieved higher open circuit voltage, photocurrent density, and efficiency from 0.2 to 0.3% than the natural dye cell under simulated sunlight. It also showed improved color stability and reduced degradation. In conclusion, co-sensitization with copper complex and silver nanoparticles improved light absorption, stability, and efficiency. Through overall efficiency remains low, the approach shows promise for future optimization in low-resource environments. I chose the zinc oxide DSSC because the silicon oxide-based solar cells, they involve high temperature processes of energy and release greenhouse gases. Also, mining quartz for silicon oxide can damage ecosystems, while chemical processing generates toxic waste that can pollute air and water. So, the zinc-based Dyson solar cells could be a great alternative, a green, eco-friendly alternative for making energy. Thank you for listening. That's all.
Thank you. We'll try again to see if Mr. Almir is
I'm
online.
sorry. Hi.
Abdullah Almir.
No. See, I know.
So, my name is Ayoma Mangoskze. So, can I share my presentation now?
Yes,
My
of
post. Mm-hmm.
please.
So, can you see? Oh, no, you can't. Wait. Can you see it now? This me?
Yes, we can see now.
Mm-hmm. So, hello everyone. My name is Ayoma Mangoskze, and I'm from the Nazarbayev Intellectual School of Chemistry and Biology Natural, Kazakhstan. And today I am very excited to share the results of my research titled Evolution of Veganum hormala. Extract as a natural shampoo ingredient. So now we live in a time when people are becoming more aware of what they use on their bodies. Many shampoos that dominate the market today contain chemical additives that harm hair and irritate the scalp. So this inspired me to look for a natural, eco-friendly alternative, something that could be both effective and sustainable. So Veganum hormala, also known as Adraspanis panis Kazakhstan, is a medical plant that grows widely in Kazakhstan. It has been used in traditional medicine for centuries due to its antimicrobial, antioxidant, and healing properties. My goal was to explore whether it could also serve as a natural ingredient in hair care product. So to test this, I used two extraction methods: ethanol extraction and the water-based extraction with yeast fermentation. The ethanol method allowed us to isolate the key bioactive compounds, while the water-based methods produced a more natural formula suitable for hair. So after testing, we found that Veganum hormone extract helped strengthen hair, added shine, and preserved natural oils better than commercial shampoos. These positive effects are linked to alkaloids such as harmine and harmaline, which promote hair growth and protect the scalp from bacteria. This research shows that Kazakhstan's natural resources can offer valuable and eco-friendly solutions for modern cosmetic products instead of depending on sustainable local alternatives that are both safe and effective. Finally, I would like to thank my mentor and teachers at Nazarbayev Intellectual School for their support and guidance throughout this project. Thank you for the listening.
Thank you too. Talab Ayn Nur is also from your group.
Hello everyone from Almir. We're from Kazakhstan, from Nazarbayev Intellectual School. Our project is about cleaning polluted water using plants, especially reeds in Israel. The Ural River is polluted by oil refinery waste, which harms nature and people. We wanted to find an eco-friendly and cheap way to clean that water. We created a prototype called Bostan, a small container with the helps clean water from oil and solid garbage. To make the reeds work better, we heated them at about 300 to 600 degrees. Also used a stone called hexane to separate.
In our experiment, we compared how well hexane and reeds clean oil from water. The results showed that the
Thank you very much, Adriana. We will take a 10 minutes break, and after that we will return with our invited lecturer and author training, actually, from our partner in DPI. A short word from the Romanian Chemical Society and the award ceremony. Those will be without a break, so please be here, because you should be here for the award ceremony. Thank you. So welcome back after the very short break. In order to be on schedule, we will start with our invited lecture and author training. Iustina Bostan from INCDCP Romania, Journal Relations Specialist. Iustina graduated in biotechnical engineering from Babeș-Bolyai University, Faculty of Biology in Cluj-Napoca, Romania. She began her career at INCDCP in 2021 as an editor for the journal Gels, where she quickly gained extensive editorial experience. Through dedication and continuous professional growth, she advanced to the role of journal relations specialist, being responsible for maintaining strong collaboration with external editors and ensuring that academic integrity and transparency in editorial processes are upheld. She now also serves as a senior conference representative for INCDCP, and we thank you once again for being here with us today. The title of her lecture will be Ethical Issues in Publishing. Iustina, please.
Thank you so much. Thank you so much for having us today. Thank you so much for introducing me, and last but not least, thank you so much for supporting open access. For us, it's really important because this is our model, and we really think this is the future. We are supporting this academic community to bring their ideas together, to share them globally, and of course, to push the innovation forward. Today, I'm speaking about publication ethics for authors. Of course, we can also speak about ethics when it comes to academic editors, reviewers, for us as internal editors, but today we will be speaking about authors. I will skip my introduction. What I would like to mention here is my email address. Please feel free to contact me at any time when you have any questions, when you have any curiosities. I'm always here to help, and it's a pleasure for me to be of help. I'm representing today two of our journals. First, I'm representing Gels, the journal where I began my career in INCDCP. Its impact factor is 5.3, and the size score this year has been increased to 7.6, which is ranked in the first quartile. And the second journal is Crystals with an impact factor 2.4 and the size score 5. It is ranked in the second quartile. I also have the pleasure of introducing the special issue launched for this occasion for PRIOCHEM 2025. The guest editors are Dr. Radu Claudiu Fierescu and Dr. Verona Iordache. Congratulations. You are welcome to submit to this special issue. Of course, you can apply for a discount request to me or to one of the guest editors, and we will be happy to analyze them. The journal has an impact factor of 4.9 and the size score is 9.7. Here you have a QR code and you'll be redirected to this special issue. Now let's talk about today's subject. We will introduce you in this publication ethics. We will talk about some common author misconduct. Maybe you are wondering how editors detect and address some problematic articles. I will also talk a while about the AI in publications, and I will not leave this room without some takeaways. So ethics represent an important aspect when we are talking about academic publishing. A lot of papers, more than 800 papers has been retracted due to data or authorship issues in the chemistry or chemical engineering, as well as materials field. And it's really important to be educated on these small details that can lead to an ethic issue. So when we are speaking about publication ethics, it refers to ethical standards, policies, and guidelines to be sure that we keep the integrity, quality, and validity of our research. So this is really important because, of course, a bad research can waste the time and resources. And it's important to know that even a small detail can lead to an potential ethic issues that can leave a mark on our career, not only on authors, but also to the reviewers, academic editors, and us as a publishing house. So it's important to make collaborative efforts to uphold the integrity of the research. These ethical cases can be related to the editorial process, to the authorship and contribution, to the image and data validity, of course, to the ethical oversight, participant protections, to the informed consent, and of course, to the intellectual property. We in MDPI, as we are a member of COPE, the Committee on Publication Ethics, they have a full list of guidelines and policies. We must adhere to them, as well as to others committees like Consort of Fair Principles, Prisma, Arrive, and there are a lot. So we really hope that soon they will be known to everyone, and we will be aware about what an ethical issue can lead to, and of course, how we can avoid them. So an ethic issue can be related to the duplicate or simultaneous submissions. They can be related to the data falsification, to the plagiarism, to the citation manipulation, image manipulation, to the copyright infringement, to the data fabrication, to the authorship issues. Of course, if no permission for data usage, there is also an ethic issue. If there is no informed consent, as well as no declaration of conflict of interest. And last but not least, there is a special case called salami slicing, and I will talk about this a little bit later. We can talk about each one of these issues. The first and the most frequently encountered form of academic misconduct is that data falsification. It refers to dishonesty, fabrication, and falsification of data, to the fabricated data, images that can lead to misleading results. It's a very important aspect. As you can see, 3.8% of papers published in biomedical journals contain problematic figures. It is a real problem because more than 2,600 papers and 40 journals between 1996 and 2014 has been affected. And we left here an example, a clear example of manipulated Western blot way. These images has been cloned, flipped, shifted, and rotated. So it's really important to be transparent and fair when we are presenting our results. The next one, the most easily detectable form of academic misconduct is plagiarism. And it refers to the unauthorized use of someone else's work without properly citing the work, and it's including the self-plagiarism case. This self-plagiarism also refers to the text recycling, which is commonly described as recycling or using our own work for other studies. The plagiarism takes different forms. It can be related to data, to the words and phrases, and to ideas and concepts. Of course, it has different levels of severity. It can be related to the experiments and methods part, which is more accepted than the introduction and discussions part, which of course the most, let's say, the less accepted part, where you will find the cases of plagiarism. There are the conclusions part. So of course we are also open to analyze each case. Just because the similarity rate is high, it doesn't mean that it's indeed a problem. But of course, we must be, once again, fair and transparent. So to avoid these plagiarism cases from the author's perspective, it's important to have short quotes and quotation marks and the original sources to be cited, to obtain the permission before publishing your studies, and of course to paraphrase the methods and literature reviews that you are using. Then we have the most serious form of academic misconduct, and this is the ethic violation. Ethic violation refers to the research that involve human and animal subjects. Of course, each study that involves human subjects, human material, human tissues, and human data should follow the rules of the Declaration of Helsinki. This is way too complex to be discussed in 30 minutes, so that's why we only left here the link, and you are really encouraged to check it. Then this kind of research, they also need to have ethical approval, and the authors must provide the review board which contain the institutional review board, which contain the name of the ethical committee, the approval, and the date. Then they must have the informed consent. The authors need to provide the blank consent form. And last but not least, they need to have a permission to publish. So it's important to provide the blank consent form, including the name of the journal. We also have the case of multiple publications. It can refer to simultaneous submissions when the authors submit a paper to multiple journals. We also have duplicate or multiple publications. It's different because it refers to the moment when two or more papers share essentially the same hypothesis, data, discussions, points, or conclusions without cross-referencing them. And as I mentioned about salami slicing, it refers to a paper that has two or more, the authors that have two or more articles based on the same data collected from a single study. Then there is an undisclosed conflict of interest. Here we have a different committee. We have International Committee of Medical Journal Editors that define this conflict of interest as any relationship or activities that readers could perceive to have influenced or that give the appearance of potentially influencing what you wrote in the submitted work. So either we are speaking about financial interest or non-financial interest, they must be declared. And it's important to know that a conflict of interest is not inherently wrong, but it must be disclosed, and it's unethical to keep it for you. So that's why even when you are submitting to us, you will have to complete a form, and here you must declare if there might be a potential conflict of interest in your paper. We also have issues related to the authorship. Then we have the ghost authorship. It means that someone who makes significant contribution to the work, but he is not acknowledged on the work. We also have guest authors. It means that an author have no meaningful contributions, but However, they are cited into the work and they are mentioned in the authorship list. And we also have gift authorships. It refers to the moment when we are attributing authorship on a weak or connection to the study. They have no role in the research, and of course, they do not satisfy the criteria of the authorship. After all these issues, it's, of course, we need to make collaborative work to keep and uphold the integrity, but it's our job to detect and address them. So for this, we have international guidelines. We have the Committee on Publication Ethics, COPE, that I mentioned before. We also have the International Committee on Medical Journal Editors. They also have a lot of guidelines and policies that must be respected. And we also have our own policies and guidelines that can be checked on our website. And of course, you are encouraged to do this before submitting your work. First, our editors are using Authenticate, which is a platform that compares manuscripts to its property cross-ref database, and it includes a vast collection of documents. It's a quick way to detect plagiarism, the duplication rate, and so on. Of course, there are also a few acceptable cases. You are free to use common words, phrases, and definitions. It can be happen in math and physics. Of course, there might be a high duplication rate on the material and methods part, especially when we are talking about the chemistry field. There can be conferences, papers. Of course, it might appear to be plagiarized, but if they are enough extended and you have the permission, then of course they can be published. And we are also we also permit to publish works already published on preprints or other pre-publication databases. Beside this similarity report, then if the year 2024 found us with 6,500 employees, now 2026 will find us with 8,600 employees. The checks, we have to do more checks on the work. Of course, we also implemented an AI tool, but we know that it doesn't work itself. We need more human being to check what they say, what they do, what they find. So beside this, we also have our reviewers, authors, and academic community that inform us about every issue that may be present in our works. And of course, we also have other literature research for related papers, so we can check them before publishing a paper. If an ethical issue is detected, then it can lead to withdrawing the paper if the paper is still under processing, or we can correct it by correction or retraction, depending, of course, how serious is the case. And all of these are done after a complex investigation, and the final decision is usually done by the editor-in-chief. Of course, COPE recommends an educational approach as the first step, and that's why we are here today. We are trying to connect with the academic community to educate each other and to be sure that when we start to do something, we already have enough information and each decision will be a well-informed decision. Last but not least, I will also talk a little bit about AI in publishing, because we know it started to be present in our daily work. And somehow it is not longer an option, but is a must for every major academic publisher, including MDPI. So it's fine to use it. It is used by scientists to polish their language, to summarize research literature, to brainstorm research ideas, to write presentation emails and so on, or even to write course work or exam questions. By us, by publishers, it is used to find reviewers, to check papers for ethical concerns, to check reports, to find authors, to write emails, and to provide customer support. And I'm speaking about those chat box. But there can be also some problematic use cases when authorship attribution debates, when it makes the plagiarism easier and harder to detect, when it brings mistakes or inaccuracies to any papers. Because most of us probably are already using ChatGPT. COPE, the committee we are a member of, already has a position statement on this. As my colleague from Frontiers have the pleasure to share with you yesterday, the AI tools cannot be listed as an author of the paper because, of course, the AI tools cannot meet requirements for authorship as they cannot take the responsibility for the submitted work. So it's important that the authors who use AI tools in the writing to be transparent, to disclose how the AI tool was used and which tool was used. And of course, the authors are fully responsible for the content of their manuscript, and it's important to be, once again, transparent and honest. In the recent years, it has been used to generate text, refine language, and to brainstorm ideas. We know it's attractive to the authors, but we must be sure that it should be responsibly fit into the academic publishing. And here is an example. They are from 2 or 3 different published works. And you can see that here the text from AI tool was left here. It was really easy for us to detect it. But of course, it's really important, even though you are using it, to check everything to be sure that the study and the main information of your work is preserved. And of course, we are not living without some takeaways. It's important to understand the authorship criteria, to maintain the transparency, to use proper citations, practices, to use plagiarism detection before submitting your work, to document research procedures, to follow up ethical guidelines, to seek guidance and ethical issues, and of course, to promote the integrity in research. We are open, and that's we are here to let you know. We will be happy to have more collaborations and be both implied in these actions on keeping the integrity of academic publishing. So every time when you notice something that may be a potential ethical issue, please do contact us, and we will already start the investigations and inform you about the results. So thank you so much for your time, for your attention. And if you have any questions, I'll be happy to answer them.
Thank you very much, Iustina. And as I've seen, you didn't put it in your presentation. The works presented at PRIOCHEM can be published in 2 journals. In Polymers is a special issue dedicated to this conference, and also in Frontiers in Materials. So feel free to choose your best fitting journal. Now, if we have any questions from the room, I've already seen you. Okay, so if you are the bravest.
Sorry to be the first. The question was related, one question, one comment. The question, what about recycling your young text into the materials and method section?
So as I mentioned, in the chemistry field is something normal, so it is accepted. we understand that it's really hard to rephrase, to find other ways to share that information. So of course this is acceptable, and the methods and materials part is more accepted. I mean, the mostly accepted part in when it's coming to speak about the similarity rate.
But as usually, you need to be transparent and to quote your previous paper. And it's also, and I have a comment regarding salami slicing. It is possible to use the same data if you have a different research hypothesis.
Correct. This is correct. Thank
Yeah.
you so much for adding this.
Thank you very much.
Hello. First of all, I'd like to thank you for this nice presentation.
Thank
And
you.
also, I'm a big fan of MDPI. I have a lot of publications in polymer and in pharmaceutics. But I have just a note, because I'm an editor in Springer Nature, several journals. Now we can decrease the retraction rates by also, in addition to Authenticate, because Authenticate only detect the plagiarism. You have now several advanced software that can detect plagiarized images. I know that maybe if it's something new, it will not detect it, but this will decrease the retraction rates maybe by 30 or 40%, which is good for the journal, because also if the retraction rates are high, this means that the reviewing system is not appropriate. So why I'm asking, why don't you adopt an approach in order to check each submitted paper against figures, against duplicated figures? You have now advanced softwares like Proofread, for example.
So we have an internal AI tool that checks this, but of course this is not perfect, as I mentioned. So we are working on improving it. That's why we also hired more people, especially for such cases when we really have to double check what the AI tool says.
So you are doing this.
Yes,
which
we
is
are.
good, because you can filter. Also, you can filter. I mean, also some papers will be retracted if it has issues, but I mean, this can be decreased if this is adopted, because now a lot of journals in Springer Nature and Elsevier have started doing this in addition to Authenticate and turn it in for sure. Okay, I have another question regarding the use of AI. I think there is a contradictory. Now, MDPI encourage the use of AI, but at the same time, it doesn't encourage it. So if someone, for example, used it, because also this problem faced me as an editor, if someone used AI for polishing, but the scientific ideas and data are for sure generated by humans. So should this be acknowledged in the acknowledgement, or?
So it's important because every detail that can lead later to an ethical issue that can be avoided in an early stage, and it just by disclosing it, then it will be much better, because might be just about polishing the language, but if something will be then found by a reader and they complain to us, and we somehow find the work suspicious, or our editors really lose their credibility into the research, it can lead to a bigger case. So if everything is disclosed at the very beginning, it can save our time, our reputation, our work, everything.
So you encourage to add it as an acknowledgement, right?
Correct. So
But also,
AI,
I have a question. Sorry to be interrupting you. How can they differentiate between polishing and genetic idea? Because, for example, if we use, sometimes I use this for my students to enter the, for example, assignment to AI detector. It gives you that, for example, it's 50 or 60% AI generated, while they are used for polishing it. So how can you differentiate between polishing and generating of ideas? This is hard. I mean, I think
it's really hard. There is a fine line. We as internal editors, maybe for us, it's really hard to detect it. There might be some escapes that our academic editors may notice, because there is a different way to expressing the things. It's a different way to expressing your research work. So probably someone more experienced than us can detect them. But for us, it's really hard to detect if something is generated by AI or something is only reshaped by, when we are talking about the text, because for images and other tables and other parts in the work, they might be easier to be detected. But when we are speaking about the text, it's really hard. So that's why it's important to be fair, to be transparent, and to be sure that at the very beginning you already disclosed how did you use the AI and what AI tool you used.
Thank you so much for your time. Thank you.
You're welcome, and thank you so much for your questions.
Thank you. If we have any other questions, please. I don't think we also have anyone from online. Thank you very much, Iustina, and thank you very much for addressing very delicate issue, the ethics in research.
And I will be in the waiting room. If you have any other questions, I will be always happy to answer, to discuss, and so on. So thank you so much.
Thank you. I will now invite Sir Andrei Sârbu, as the chairman of branch 3 of the Romanian Chemical Society, to our partner in organizing this event, to address us a few words.
This is the last part of this symposium, and because I will speak about activity of a branch of Romanian Chemical Society, I prepared this presentation in Romanian, and I will speak in Romanian because I think that the guests are not interested about our internal problems. Vreau să vorbim despre activitatea filialei București 3 a Societății de Chimie ca un exemplu despre ce face Societatea de Chimie. Multă lume în institut și în alte institute și în universități se întreabă, dar la ce e bună această Societate de Chimie? De ce ne trebuie nouă așa ceva? Vorba lui Topârceanu, ce aveți noi cu noi să ne pune să dăm cu var? De ce să dăm noi cu var popor? Nu vrem. Așa, asta este întrebarea care o întâlnesc des. Și atunci mi-am pus în minte să vă prezint cam ce face filiala 3 București a Societății de Chimie. Deci, în primul rând, trebuie să știți din cine este formată filiala 3 București a Societății de Chimie. Inițial a fost formată din aproape toate institutele de chimie din București, și anume din ICECHIM, Institutul de Chimie Fizică al Academiei Române Ilie Murgurescu, Institutul de Chimie Organică și Supramoleculară al Academiei Române Costin D. Nenițescu, Institutul Național de Cercetare-Dezvoltare pentru Metale Neferoase și Rare IMNR, un colectiv al Institutului de Cercetări pentru Electrochimie și Materiale Condensate PATLAB, care se află în București, este în cadrul clădirii ICF, CEPROCIM-ul, care e o bucățică mică din ceea ce era înainte acest mare institut de cercetări pentru ceramică. Aceasta era situația în ianuarie. În ianuarie, filiala 3 București avea 173 de membri, cu cotizația plătită la zi, și anume 47 în ICECHIM, 34 la ICOS, 43 la ICF, 31 la ECOIN, 8 la INCMC PATLAB, 8 la IMNR și 2 la CEPROCIM. De menționat că în prezent s-a format o nouă filială, ECOINDU, care e departe de restul celorlalte institute la marginea Bucureștiului, a creat și avea suficienți membri, a creat o filială proprie, filiala București 4, și în urma procesului de reînscriere, pentru că s-au făcut niște modificări în secții și grupuri de lucru, filiala are în prezent 118 membri reînscriși. Activitatea filialei se desfășoară pe următoarele direcții: stimularea activității științifice a institutelor componente, atragerea tinerilor spre chimie și cercetarea chimică, prezentarea importanței chimiei și a rezultatelor cercetării chimice în mass media și întărirea capacității organizatorice a filialei prin sporirea numărului de membri. Lucru care este destul, ultimul punct, nu o să vorbesc despre el, dar menționez acum că este un punct greu de realizat în condițiile în care mulți cercetători ies la pensie și nu mai rămân, din păcate, în cadrul filialei deși cotizația lor este modică, 10 lei pe an, deci nu e o valoare, dar nu mai consideră că e necesar, iar foarte mulți tineri care au venit în institute, datorită condițiilor economice și care vor fi din ce în ce mai grele, părăsesc activitatea de cercetare, se duc în diverse alte părți și ca atare nu mai activează în filiala noastră. Ce înseamnă stimularea activității științifice a institutelor componente? Principala preocupare în acest sens este sprijinirea simpozioanelor tradiționale și a conferințelor organizate de institutele componente. Mă refer aici la simpozionul internațional PRIOCHEM, la care suntem prezenți, la conferința internațională XXIsT, care este organizată de ICF, din păcate n-am mai organizat-o de cam mult timp, și simpozionul EmergeMat, un simpozion emergent, nu numai prin faptul că se ocupă de materiale emergente, dar este un simpozion relativ nou creat, deci de vreo 5 ani, care zic eu că are o evoluție frumoasă și în care se investește multă inimă pentru ca să se desfășoare bine. De asemenea, sprijinim participarea cercetătorilor, a membrilor filialei, la simpozioane internaționale, IUPAC, Conferința Națională de Chimie, ZAI și interne. Deci, Conferința Națională, ZAI, RICE, SICHEM. Apropo de SICHEM, pe 6-7 noiembrie avem o nouă ediție a acestui simpozion de renume, foarte bine organizat de domnul profesor Tănase Dobre. Vă invit să participați cu lucrări și să participați la lucrări. Se desfășoară la Politehnica din București, aici pe Splai. Deci este foarte ușor de ajuns la el. În ceea ce privește atragerea tinerilor spre chimie, asta este o preocupare de bază a filialei noastre și în general societății de chimie, deoarece ei reprezintă viitor. Deci trebuie să fim foarte mult aplecați spre atragerea acestor tineri în activitatea de cercetare chimică și în acest sens noi, filiala noastră, ne-am implicat în primul rând în organizarea simpozionului NextChem, care este o reluare a unui simpozion mai vechi al ICECHIM-ului din anii 80, microsimpozionul ICECHIM, este dedicat exclusiv tinerilor și este dedicat exclusiv lucrărilor orale, pentru că intenția organizatorilor, a conducerii institutului și a societății este să învățăm pe tineri să facă o prezentare orală și să răspundă la niște întrebări științifice. Ei trebuie puțin antrenați și mai ales să utilizeze limba engleză în mod fluent, că și asta este important. Din anul, de la 4-a ediție, simpozionul a devenit internațional și în 2025 s-a desfășurat a 7-a ediție. În fiecare an, Societatea de Chimie a acordat 2 premii numai tinerilor. Deci, Societatea de Chimie acordă premii la aceste evenimente tinerilor. De ce? Ca să-i atragem pe ei în Societatea de Chimie și în cercetare, să-i încurajăm să se simtă apreciați și să-și facă comparații între ei. Dacă vede că unul a obținut premiul, poate celălalt de lângă el zice, dom'le, poate și eu la anul o să obțin dacă o să lucrez mai mult și mai bine. Și anul ăsta vom acorda 2 premii pentru cei care au participat la simpozion, tineri, numai tineri, de la simpozionul PRIOCHEM. De aceea am făcut un lucru în care am avut foarte mult sprijin din partea conducerii institutului și a celorlalte institute, la chimie fizică și la ICOS, de atragerea tinerilor să efectua practica în institut. Este o metodă foarte bună. Ei acum, pentru că industria este la pământ, se duc și iau o adeverință că au făcut practică, practic nefăcând nimic. Deci nu vin cu o adeverință. Când dacă vin în institut, ei văd ce este activitatea de cercetare, se implică în această activitate, noi îi cunoaștem și putem să îi selectăm și să zicem, da, ăsta ar fi bun pentru noi. Ei pot să ne selecteze pe noi, să zică, da, mi-a plăcut colectivul ăla, aș vrea să lucrez acolo, Deci este un lucru care este benefic și care a fost înțeles și aplicat foarte bine și de Universitatea București și de filiala din Universitatea Politehnică București. Deci această atragerea tinerilor spre chimie începe, de fapt, de pe băncile facultății. De acolo ar trebui să înceapă. Avem, de asemenea, o misiune foarte grea. Să prezentăm rezultatele cercetărilor chimice în mass media. Aici trebuie să o facem mult mai multă aplecare și mai multă inimă, pentru că ne izbim de un zid. Sunt foarte mulți care prezintă chimia ca ceva nociv. Numai partea de nociv. Nu înțeleg, este pesticide, aoleu, purifica apa, aoleu, nu avem aer suficient, aoleu, avem și codoi, avem, deci e o mare nenorocire. Dar uită că fără chimie nu ar exista medicamente, nu ar exista telefonul mobil, care are o carcasă de plastic și o baterie care este pe bază de electrochimie, în care se află și un polimer, o membrană polimerică. Deci n-am avea tehnica modernă, n-am avea televizor, nu putea să avem totul chimie acolo. Da? Dar ei îl susțin și atunci noi trebuie să ne luptăm și să le răspundem în sensul că chimia are și părți negative pe care le recunoaștem, dar tot noi ne ocupăm de depoluare până la urmă, dar în primul rând este o necesitate și trebuie nu să o dăm deoparte. Ne mutăm spre chimia verde, ne mutăm spre alte direcții, dar fără să renunțăm la dezvoltarea chimiei, care este cheia dezvoltării societății în general. Aici vreau să vă spun că am avut foarte multe emisiuni, cu foarte buni parteneri am avut la Radio România Internațional și Radio România Cultural, care ne-au invitat și am făcut prezentări, doamna director Toni, domnul director Mancea, doamna Verona Iordache, Adina Musuc, Radu Fierăscu, José Calderon Moreno, este de la chimie fizică. De asemenea, domnul Bogdan Trică a participat la o serie de emisiuni la Antena 1, sub numele de Medicul. Sunt emisiuni care pot atrage tinerii pentru că văd concret ce se poate face. Am organizat în 2023 Festivalul de Chimie pe platforma ICECHIM, care a fost o foarte bună propagandă pentru institut și o reușită. Și de asemenea aș vrea să remarc activitatea depusă de domnul academician Andrei, care a promovat ICOS-ul la Radio France International, domnul director, doamna Simona Nica, și au participat la emisiuni de dialoguri academice. Acum, întrebarea este, dăm acum un răspuns la ceea ce am zis la început. De ce să fim membru al societății de chimie? La ce e bun asta? Păi, în primul rând, trebuie să spunem că Societatea de Chimie este o organizație profesională prestigioasă, dedicată celor care muncesc în acest domeniu. În al doilea rând, a fi membru al unei organizații cu peste 100 de ani vechime este o onoare. Să știți că în țările vestice, a fi membru al unei astfel de organizații este deja o carte de vizită. Toată lumea vrea să fie membru, nu să zică, aoleu, n-am 50 de lei pe an să plătesc. Aici, cel puțin la unii tineri din institut, constată această opacitate. Nu înțeleg de ce trebuie să fiu membru al unei societăți profesionale. Deci, societatea noastră s-a creat în anul 1919. Deci, imediat după război. Atunci s-au pus bazele și deci are 100 și ceva de ani, în 21 s-a înscris, dar ea era deja creată. Este o societate cu mare vechime. Societatea de Chimie Europeană a fost creată la București. Deci vă dați seama, noi am avut o tradiție extraordinară în chimie. Nu vorbim de profesorii noștri, ai mei cel puțin, Emilian Bratu, Denițescu și alții, dar și generația anterioară, cu Teclu, cu Poni, care erau unii dintre cei mai bine cunoscuți savanți în domeniul chimiei în Europa. În momentul în care ești membru al Societății de Chimie, ești automat membru și al EUCHEMS, al Societății Europene de Chimie, pentru că EUCHEMS este o asociație de mai multe organizații naționale. Societatea acordă burse pentru participarea la simpozioane interne sau internaționale. Să știți că în fiecare an se acordă burse pentru ca anumiți tineri, pentru tineri, să poată participa la anumite simpozioane la care nu au fondurile necesare să meargă. Din această cauză și a următoarei, că se oferă reduceri de taxe membrilor Societății de Chimie. De exemplu, la conferința națională veți vedea că taxa pentru membrii Societății de Chimie este mai mică. La ICECHIM veți vedea, membrii Societății de Chimie au o taxă mai mică. Aia sunt banii pe care dumneavoastră îi dați cotizații și care se întorc către membrii societății în alte forme. De asemenea, foarte important, societatea acordă premii, diplome și medalii celor mai prestigioși cercetători. Acesta este un lucru foarte important, pentru că oamenii se întreabă, oare am făcut și eu ceva? Ce am realizat? Și în momentul în care văd că obțin un premiu, o diplomă, o medalie, simt o mulțumire sufletească că activitatea lor a fost văzută și că nu au muncit chiar degeaba. Ceea ce este de asemenea important este că, cum v-am spus, suntem supuși unor presiuni foarte mari. Ați văzut, recent a fost domnul Năsui care vrea să întrebe la ce ne trebuie nouă cercetare. Da, noi putem să rămânem și proști. Adică la urma urmei, de ce să nu rămână? E mai ieftin. Nu, e mai ieftin. Dar la fel este și cu chimia. La ce ne trebuie nouă chimie? Nu ne trebuie. Și atunci scot orele de chimie din liceu, reduc toate orele de chimie de la facultate ca să fie mai lejer program și ca să nu se învețe mai nimic. Noi trebuie să luptăm cu această chestie, pentru că nu e vorba de cei care vor lucra în chimie, e vorba de cei care se lovesc de chimie în fiecare zi și nu vor înțelege. Nu vor înțelege ce este H2O, nu vor înțelege niște lucruri simple despre chimie, nu vorbesc de niște lucruri complicate. Nu vor înțelege ce e un polimer și atunci când un ziarist, că ei sunt foarte deștepți la toate, scrie o enormitate, vor crede. Așa a scris ziaristul. Deci noi trebuie să le dăm tinerilor noștri un nivel de cunoștință care să-i facă să gândească cu propriile minți și să nu creadă că pe drumul dintre Danemarca și Suedia s-a scufundat un vapor cu petrol și din cauza asta s-a format foarte mult acid și au murit pești. Era vorba că vaporul ăla transporta oleu, nu oil. Dar ziaristul a tradus petrol, oil, în loc de oleu. Da? Și atunci, dacă nu te duce capul, zici, da, domne, uite ce face petrolul. Petrolul produce acid în momentul în care intră în apă. Deci de-aia ne trebuie și trebuie să luptăm cu ei. Și de asemenea, poate că e important și asta, sunt multe funcții în care nu poți fi numit dacă nu ești membru al unei societăți profesionale. Unele organisme chiar cer acest lucru. Și am avut un caz, nu o să spun numele, din ICECHIM, care trebuia să fie numită, a cerut, s-a făcut o invitație să fie numită într-o anumită funcție la nivelul EUCHEMS și care a venit să solicite societății să îi se dea o adeverință, că este membră, ea nefiind membră, și că să se înscrie repede și că și domnul profesor Roșca, era atunci, a spus nu se poate așa ceva. Și nu i-a dat. Și uite, dacă dădea 50 de lei, nu avea această problemă, că era membră. Deci cei care se gândesc la ce ne trebuie nouă societatea de chimie, trebuie să-și pună toate astea în cap și să se gândească în primul rând la primul punct de acolo, că este o mare onoare să fii într-o societate ca aceasta. Vă mulțumesc!
Thank you very much. Thank you very much, Professor Sârbu. Now, before going to the award ceremony, I would like, because otherwise no one will be listening, I would like to thank all my colleagues that were involved in organizing this event, starting in a very random order. with Bianca. I know you are here. Yes. Ștefan, Mihai, Iulia, Lorena, the persons that the responsible for each sections that you kept in touch during the registration process, Verona and Cristina, Anda, Toma, who also helped you these days. Also, as a little insight, especially for our colleagues, the ones who are participating at the event exhibition in Cluj-Napoca, it seems that we have some wonderful news, but after this conference.